In September 1899, the whole of France was waiting for news of the sensational trial of Alfred Dreyfus, a captain of Jewish descent in the French army. In his celebrated article, J'accuse, Émile Zola criticized the dubious circumstances under which Dreyfus had been found guilty of treason. Zola's impassioned open letter triggered off a storm of international protest. As a result, Dreyfus was given a retrial in Rennes in Brittany. However, telegrams sent by reporters in court never reached their newspapers' offices in Paris. But why not? In Paris, meteorologist Léon-Philippe Teisserence de Boer had sent up 11 kites containing measuring instruments. The kites were secured by a length of wire, but it snapped. When the trailing wire came into contact with the telegraph line, it caused a massive short circuit. So who was this man whose weather kites severed all communication links with the capital? The son of an engineer, Léon-Philippe Teisserence de Boer was born in Paris in 1855. He showed an early interest in the movement of clouds and built various kites for observing the weather. In 1892, he was appointed head of the Central Meteorological Office in Paris. 4 years later, he gave up the post to open a private observatory in Trappes, west of Paris. Teisserence de Boer was now able to devote all his time to his research. He developed a new measuring instrument, the photographic theodolite. In 1896 and 1897, it enabled him to make the first accurate measurements of the height and speed of clouds. He continued his research with kites he built himself, and from 1898 on with balloons, which at last enabled him to study the upper atmosphere. His balloons reached air strata at an altitude of more than 10,000 meters. De Boer tirelessly filled one paper envelope after another with hydrogen or helium. Carrying measuring instruments, they soared for the first time to altitudes of up to 14 kilometers. However, in the extremely thin air at such heights, the gas expanded and sooner or later the envelope burst. The measuring instruments then floated back down to Earth on parachutes. By 1902, Teisserence de Boer had launched more than 230 balloons. When evaluating the data recorded, he noticed that up to a height of 11 kilometers, the atmospheric temperature decreases every 1,000 meters by roughly 5.5 degrees Celsius, but between 11 and 20 kilometers, it remains the same or even increases. At first, he thought some measurement error had occurred, but in Lindenberg near Berlin, German researcher Richard Assmann had come up with similar findings. Since they'd obtained their values working independently of each other, the two scientists were able to rule out the possibility of error. In 1902, they published the results of their research. Contrary to expectations, the atmosphere is not a uniform body of air enshrouding the Earth, but is comprised of separate layers. A discovery that constitutes a milestone in the history of meteorology. De Boer believed that the atmosphere was divided into two layers. He called the lower layer the troposphere. It extends to an altitude of 6 kilometers over the polar regions and 17 kilometers at the equator. The troposphere is the source of all our weather. De Boer named the upper layer the stratosphere. He thought there were no air movements in it. However, we know that clouds of ice occur in the lower areas of the stratosphere. At an altitude of between 25 and 35 kilometers, it has a very high ozone content. That's why it's also known as the ozone layer. Another interesting feature of the stratosphere is that in its lower portion, the temperature remains nearly constant with height, roughly minus 55 degrees Celsius. But in the upper portion, it increases rapidly with height to 0 degrees. At an altitude of 80 kilometers, it drops again to minus 90 degrees. Besides the two layers defined by de Boer, there is also the ionosphere. Its existence was proved experimentally in 1924 by British physicist Edward Appleton. This layer of the atmosphere, which begins at a height of 80 kilometers, reflects certain radio waves, enabling them to bridge large distances. Since temperatures in the ionosphere, which extends to a height of 300 kilometers, rise again to nearly 1,000 degrees, it's also known as the thermosphere. Above it, the atmosphere slowly merges with outer space, and temperatures drop once again to absolute zero. Today, we know not only the structure, but also the exact composition of the atmosphere: 77% nitrogen, 20.7% oxygen, and 1.3% water vapor. The remaining 1% is made up of inert gases, carbon dioxide, and ozone. Through gravity, nearly 75% of the entire volume of air in the atmosphere is concentrated in the lower layer, the troposphere. This is where many climatic phenomena occur, including the greenhouse effect. The main greenhouse gases are water vapor, carbon dioxide, and methane. They act like the panes of a greenhouse. Sunlight can reach the Earth unimpeded, but only part of the heat that is radiated can flow back into outer space. Most of it is trapped inside the greenhouse. There is also a beneficial side to the greenhouse effect. It ensures stable temperatures on Earth, without which life would never have been possible. But ever since the age of industrialization began, humankind has intensified this natural greenhouse effect and permanently affected the world climate. Average temperatures are constantly rising. Unlike the unmanned balloon probes used by Teisserence de Boer, manned balloons have a long tradition. In 1783, the Montgolfier brothers launched the world's first hot air balloon. More than 100 years passed, though, before it became technically possible to make safe balloon flights at a great height. After Teisserence de Boer's advance into the stratosphere with unmanned research balloons, science wanted to send a manned balloon to explore this mysterious layer of the atmosphere. In 1901, two German meteorologists, Reinhard Suring and Arthur Berson, reached an altitude of 10,225 meters in the balloon Teisserence. Just before they lost consciousness as a result of hypoxia, lack of oxygen, Berson managed to initiate descent. The balloon still continued to rise for a while, but only the barometer witnessed the fact. The chase for records also claimed its victims. On his first attempt to enter the stratosphere, American Army Captain Hawthorne Gray saved his life with a brave parachute jump from 13,000 meters. But on his second descent in 1927, he passed out and died. The first men to make a successful ascent into the stratosphere were Swiss physicist Auguste Piccard and his partner Paul Kipfer. In 1931, they reached an altitude of more than 12,000 meters. Auguste Piccard was born in Lutry in the Swiss canton of Vaud in 1884. In 1922, he was made professor of physics at the University of Brussels. To combat the problem of hypoxia, in 1931 he developed a spherical aluminium cabin with its own oxygen supply. Since the cabin was airtight, the pressure inside could be kept constant. Piccard also had the gondola painted black to maintain a reasonable temperature at icy heights. Since the pressure of the air at altitude is extremely low, the gas in a balloon's envelope expands. So at ground level, Piccard used only 1/7 of its capacity. Rather slack when he took off, at altitude the skin was stretched tight. Piccard's record-breaking attempt aroused international interest. With the press covering everything in detail, the giant dark yellow balloon was prepared in Augsburg in southern Germany. Finally, on May the 27th, 1931, the big day dawned. After only half an hour, Piccard and his assistant, 26-year-old Paul Kipfer, had reached the then inconceivable altitude of 15,785 meters. They were the first humans to penetrate the stratosphere. The balloon landed 2,500 meters up on the Großgurgler Glacier in the Austrian Alps. Even the operation to bring down the two pilots and salvage their gondola turned into an adventure. The press had a new hero. But Piccard still wasn't satisfied. On August the 18th, 1932, he set a new world record with an ascent to 16,200 meters. But this was broken a short time later by his twin brother, Jean. Setting records, though, was never Auguste Piccard's main aim. He wanted to learn more about cosmic radiation and the electricity in the air at such altitudes, which is also responsible for the northern lights, the aurora borealis. On the one hand, he was convinced that the air travel of the future lay in the stratosphere. On the other, he believed that cosmic radiation in the stratosphere was the result of nuclear transformation processes, and as a result, sent in a new, unlimited source of energy. Later, Auguste Piccard ended his research into the stratosphere and turned to the other extreme, undersea exploration. In 1946, he built his first bathyscaphe, a submersible craft for descending into the depths of the ocean. In January 1960, Piccard's son Jacques and American Naval Lieutenant Donald Walsh descended to the bottom of the Marianas Trench in the Pacific on board the submersible Trieste. They reached one of the deepest points on our planet, 10,916 meters below the surface. But the fascination of ballooning appears to be in the Piccard's blood. After several abortive attempts, in 1999, Bertrand Piccard, Auguste's grandson, took off from Switzerland with British hot air balloon flying instructor Brian Jones on a non-stop balloon flight around the world. In less than 20 days, they covered more than 45,000 kilometers in their high-tech balloon, Breitling Orbiter 3, and landed safely in the Egyptian desert. But the era of scientific balloon flights is by no means over. Even today, balloons still play a crucial role in atmospheric research. In addition to aircraft, balloon probes are also used for obtaining data from the troposphere and the stratosphere. The accuracy of modern weather forecasts is only possible because dozens of weather balloons are launched every day. Even in astronomy, balloons are still used as a cheap substitute for satellites. When balloonists today try to set new altitude records for manned flights, their efforts are of just as much interest to science as they were in Auguste Piccard's day. Like Britain's Andy Elson and Colin Prescott in their gigantic balloon Kinetic 1, adventurers try time and again to venture into new dimensions. With a craft as high as the Empire State Building, Elson and Prescott hope to reach altitudes of more than 40 kilometers, higher than man has ever soared before in a balloon.